Hi, my name is Simon Gurung and my student ID is 77494463. So this is my poster for my dissertation and my title is Housing Price Prediction Using Deep Learning Model. So let's go to the overview. The real estate market has been an ever-growing industry ever since the Industrial Revolution. Every person wants to buy a new house and know the current housing pricing available in the market. So, a housing price prediction plays an important role for buyers, sellers, developers, investors involved in the real estate market. With the advancement of AI, now it is easier to predict the result with more accuracy. So, our paper explores the analysis of deep learning model like artificial neural network, back propagation neural network, and deep neural network for housing price prediction. And and a Streamlit-based dashboard is created for real-time housing price prediction, which allows users to interact with different deep learning models for their preference. Now let's go to the aim and objective. The aim of this paper is to accurately predict the housing price prediction using deep learning model by analyzing relevant features within the dataset. Now the objectives are as follows: to continue to collect the relevant data set for training of deep learning model, to identify the key features in dataset like area, number of bedrooms that influence the housing price, to select the optimal deep learning model suitable for the housing prediction with available dataset, to train the model, evaluate its performance and compare with other machine learning model, to build a user interactive web application integrating the model which helps the users to get useful insight on the housing market trend. So here's the rationale of this paper. The real estate market in Nepal has gone through a series of rapid urbanization, inflation, and post-COVID recovery, making the housing price prediction a crucial tool for buyers and sellers. The current method of determining the housing price depends heavily on word of mouth and intervention of brokers that manipulate the housing price randomly. The Western society has already adopted various machine learning models to predict the housing price, whereas it is still a new thing in our country or society. So let's go through the literature review. So the random forest performed based on housing data but had overfitting problem. XGBoost has been widely adopted because of its ability to process a non-linear relationship in data. Although XGBoost performs well, its complex algorithm may lack interpretability, which might be difficult for the end users. Naive-Bayes is less suitable for regression tasks because of its classification-based type. Deep learning models like BPNN and DNN have stronger performance in dealing with data intricacies. Deep learning model provided more reliable and unbiased price prediction, showing its competency for the traditional model. PCA DNN outperformed standard DNN in other regression-based deep learning model in handling high-dimensional small data set. So PCA means principal component analysis. So this model can handle high-dimensional small data set. So let's go to the methodology of this paper. This paper follows the following methodology in systematic order. So we have data acquisition, data pre-processing, feature engineering, model selection, model evaluation, and dashboard deployment. So in data acquisition, we acquire the data from open source like Kaggle, and in data pre-processing, there are several feature engineering techniques applied in the data. Let's discuss some of the feature engineering techniques that are applied in the data. First is label encoding. Label encoding changes the categorical value to a unique numerical value. And now feature scaling. In feature scaling, numerical features are fine-tuned and normalized. Standardization helps in stable training. Without it, the features with large number range, the features with large numerical range influence the model. Log transformation. Log transformation helps skewness. Example, high in housing pulling the average price upward. So that means, so if the luxury housing prices are there, then that pulls the average price upward. And outlier removal like IQR helps to eliminate the outliers. So these are some of the feature engineering techniques that are applied in the dataset. And in model selection, we select appropriate deep learning model for the dataset. And before selecting the model, there are few hypermeters that are tuned for the selected model. Let's talk about some of the hyperparameters. So before talking about hyperparameters, I'd like to I'd like to say that deep learning models are basically uh, in deep learning model, TensorFlow Keras framework is basically used in deep learning models. And now let's talk about the hyperparameters that are used in the deep learning model. Railway activation function allows effective weight updates. And next one is Adams optimizer. Adams optimizer calculates adaptive learning rates for each parameter. And now we have early stopping. Early stopping is used for overfitting. It halts the training if there is no any improvement. Reduce LR on plateau. Reduce LR on plateau, adjust the LR. LR means learning rate by reducing it if there is no change in validation loss. Now dropout. Dropout deactivation, the fraction of neurons in training. So these are the some of the hyperparameters that are used to enhance the model for better prediction. So, and now there is model evaluation. In model evaluation, we use some of the model evaluation metrics like RMSE, MEC, MAE, R square, and then we deploy a dashboard for the prediction. So before going to the research outcome and discussion, let's see our dashboard. So this is our housing prediction dashboard. So you can see in the sidebar there is user input. We have the predict price button. Here are some of the visualization graphs. We'll talk about the visualization graphs later. So let's put some input at first. Let's put some random input. Under construction, no. Rera of BS. Let's give the number of BSK 3. Of course, it is a BSK. Let's put the square footage for now, maybe 1200. Ready to move? Yes. Resale, it is resale. It is easy for resale? Yes, of course. Let's put the default longitude and latitude. Now let's predict. We can choose our three model of choice for prediction. Let's choose ANN for now. Now let's predict the price. So the predicted price for the given input is 65.36 lakhs using the ANN model. And let's see the performance metrics of the ANN model. So these are the metrics and its value, and it's pretty good, I would like to say, for ANN 0.4 and 28 RMS ENR square. So this is the model training loss comparison graph. Like we can see, the loss has been gradually decreased as the increase of epochs. So that means the training, so the loss, So the training loss has been gradually decreased, which means the model is performing well. Now let's see the feature importance bar. So from the feature importance bar chart, we can clearly see BSK number. BSK number means number of veterans 2, 3, 4 has the highest feature importance in the dataset. Now let's go to the correlation heat map. And in correlation heat map, we can see BSK number and target value price has the high are highly correlated. We can see from the our let's see, look, BSK number and target price has 0.38, and the second highest might be RERA and under construction with 0.37. So this is our dashboard. We can choose other models for prediction too. Now let's go to, sorry, now let's go to our, yeah, let's go to our research outcome and discussion. So yeah, so we can see BPNN and DNN has better performance than ANN with 0.52 and 0.51 R square. The RMSE are almost similar. Here is the color for every evaluation matrix, and these are the same thing from the dashboard. So let's go to the conclusion. So this study demonstrates the effectiveness of deep learning models ANN, BPN, and DNN in predicting housing price. Among the model, DNN and BPNN achieve better results, indicating its capability in capturing complex nonlinear relationships in dataset. The findings supports deployment of neural network in real estate, offer valuable insights for developers, investors, and urban planners with data-driven decision-making tools. Further work may focus on integrating spatial features and enhancing model generability across broader geographic regions. So we have here the ethical consideration. So the primary data collection was not implemented since user participation was not involved. Secondary available housing data was collected from Kaggle. All the ethical guidelines of the university were properly followed, and ethical approval was granted by the university research committee. And these are the reference. And that's it for my dissertation topic. Thank you.